Okay, welcome to section 2 of chapter 5. Here we're talking about forces and forces acting on objects. Okay, so we're not talking about Star Wars here. We're talking about a force in the scientific sense that pushes or pulls. So right now, look around the room and just take a look at the objects in terms of force. All right, so a force is always exerted by one object on another object. So where do you see a force happening in the room right now? Which object is exerting the force and which is receiving it? Hopefully you're not thinking about how you could exert a force on a younger sibling or on your cat, but you could, I suppose. So right now I'm sitting in a chair in a classroom, and I'm exerting force upon the chair and exerting force upon the floor and upon the earth's surface. All right, in a minute I'm going to talk to you about other forces that are happening while I'm just standing here. I want you to think about a force you're seeing right now. So in this section, we're going to talk about forces. We're going to talk a little bit about something called a net force, unbalanced and balanced forces. So in science, a force is simply a push or a pull exerted on an object in order to change the motion of the object. All forces have both size and direction. So we can measure how strong a force is, okay? And this idea of exerting is just a fancy way of saying acting on, okay? Or acting upon, all right? So these forces act on, or they're exerted on other things. So a force can change an acceleration of an object. We talked about acceleration today in class, or yesterday for others. An acceleration could be a change in the speed or direction of the object. We learned that, okay? So a force can either increase acceleration or decrease, or make an acceleration decrease or decelerate. So we organize and we measure force in newtons. That is the SI unit, okay? So you can't always see some force being exerted. For example, gravity is invisible, magnetic force is invisible, subatomic particles, there's certain forces within an atom that causes it to have its shape it does, that's invisible. You can't always see them, all right? So gravity is the best example of that, right? So right now, we are on planet Earth, okay? And let me think back to my example here. So I'm standing here on planet Earth along with you, okay? So right now, gravity is exerting a force down on me, right? So it's pushing down on me, and at the same time, I am exerting an opposite force in the opposite direction, okay? So actually, I'm going to draw that down here. Erase that. And I am standing, exerting a force on the Earth like that. So here we have these two forces, and gravity is pushing down on us at all times, right? So it keeps us from floating off into space. It holds our planets in alignment, and it's probably the most important force that you experience on a daily basis. We're going to learn all about gravity in another section coming up soon. So there's usually more than one force acting on an object, okay? What we call the net force is a combination of all the forces acting on an object. So have you ever heard someone say net worth, right? Like, you might say Alex Rodriguez has a really high net worth, right? So that's basically all the money someone is worth, right? That's their net worth. So net is a term meaning like total. So net means total, all right? So when we combine forces, we say that's the net force, okay? So figuring out the net force depends on the direction of the forces, all right? So if I'm pushing a block, I can push the block that way, right? Remember we talked about motion, direction is really important, or I can push the block that way, and I can figure out what the total net force is on this block, all right? So let's say I'm pushing the block this way with 10 newtons of force, and I'm pushing the block this way with 5 newtons of force. Well, I can figure out what the total net force is just by doing some quick math. I'll show you about that in a second, all right? So the net force, remember, is the total force. remember, guys, when I'm writing these kind of weird little notes and things, some stuff like this is helpful to write down. I think you should write that down on your notes too. So when you push in the same direction, you can kind of add that force together. So let's say we're pushing in the same direction, we always add those forces. That kind of makes sense, right? You're gonna have some addition, right? So think back to my example before. So if I have my block here, and I'm pushing up high with 10 newtons, and I'm pushing down low with 10 newtons, I could say that the total net force is 20 newtons, okay? So, but what if I push in opposite directions? If they're pushing in opposite directions, you have to subtract the smaller force from the larger one. So think back to my example on the last page, right? So if I'm pushing, what was it? Like, let's say 10 this way, and let's say 50 this way, right? I'm going to subtract the smaller one from the larger and take 50, subtract 10. So the total net force acting on this block this time is 40 newtons. All right? So net force can either be subtracted or added. This example here. So in this example here, we've got a lady here pushing the piano this direction, and her brother or friend is pulling it in the same direction. And you add these together to the right. Notice there's a direction, it's key on there. You add those together to get the net force. Same thing with these two dogs. This dog is pulling a little harder than this dog right here. He's pulling it that way, right? So you'd subtract and figure out, well, the total net force to the right is 2 newtons, okay? If this dog was winning the pull, we'd say it's to the left. The net force is 2 newtons to the left. Direction's important, right? Okay, so when forces are balanced, we call them balanced forces. So when they have a net force of 0, when they're kind of like even, right? So you think about two people pushing exactly at the same rate, or if you're doing like a tug of war, like Tommy's pulling this way and Jack is pulling this way, and they're pulling like this, and it's just the exact same rate. Like the little flag is not going one way or the other. It's equal, right? It's kind of balanced. So you're not going to see a change in motion. If these two guys are pulling the rope exactly the same amount of force, they're going to stay right where they are. You're not going to see motion one way or the other. All right. Another way to think about this is you're not going to accelerate. Okay. So you will not accelerate if the forces are balanced. Okay. Think about it like a car moving at a certain speed, right? If there is no force acting on that car, the car won't accelerate. The car won't increase its speed. If the force is unbalanced, you will see movement, though. Okay, so and back to our other example, if Jack is pulling harder, there's gonna be motion in his direction. Okay, so it does produce a change in motion. An unbalanced force does accelerate. Okay. And back to other example, if it's balanced, you're just going to move at a constant velocity or a constant speed, okay? But if it's unbalanced, you can actually see some acceleration, okay? So things can start moving, or they can start to speed up if this force is unbalanced. All right, so another picture for you. Here's an unbalanced force here. In this example, you've got a cart here. There's a bigger force pushing in this direction with 80 newtons, and a smaller force. That might be friction in this case, right? So maybe there's like rough stuff on the ground right here, which is opposing this this cart. That might be pushing in the other direction. So what is the net force here? Well, it's pretty easy to see. I can see I've got 80, I've got 40. I'm going to subtract 40 from 80. So the net force is 40 newtons to the right. Okay, so 40 newtons to the right. All right. So there's other things that can resist too, right? So we call this like a resistant force. There's other stuff besides just friction. So friction we're going to talk about later, but maybe this is like, rough like sandpaper. So we have lots of friction resisting the bigger force, the pushing. Maybe it's windy, right? So maybe there's wind blowing here, and that wind is resisting it, right? Maybe there is an incline. Maybe this is actually going up a ramp, right? So that could be, you're pushing against gravity a little bit there. It could be a lot of different things resisting this pushing force. So technically, this bigger force, when you're pushing something like that, is called the driving force. All right, it's not going to be on any test or anything. I just want you to know that, okay? So in this case, the driving force is bigger than the smaller force, or the resistant force, and the wagon is able to move to the right, okay? Pretty short lecture. Watch it again. Make sure your notes are filled in, and you're ready for a quiz in class. I'll see you when I see you.